In this first try it exercise, we're looking at simplifying basic radicals. With part A, we're given the negative square root of 64. Remember that this negative sign on the outside is perfectly allowable. It just basically means that we're multiplying the radical by -1. So with square roots, what we want to look for are perfect squares that are factors of what's under the radical. So perfect squares that are factors of 64, but in this instance, we just need to recognize that 8 squared equals 64. So in other words, this equals, bring down the negative sign, the square root of 8 squared. And the square root of any value being squared is the value, so this is -8. So the negative square root of 64 is -8. With 225, we could factor it to try to determine any perfect squares, but really what we need to recognize is that this is 15 squared. And if we don't remember that, we can test values to see what that square is. But 15 squared, 5 times 5 is 25. Carry your 2. 1 times 5 is 5, 6, 7. Add a 0. 1 times 5 is 5. 1 times 1 is 1. Add those together and you get 225. And again, you could also factor it. If you recognize, for instance, 225 divided by 25, so this is 25 times 9, or in other words, 5 times 5 times 3 times 3, and if you'll notice, that's 5 squared times 3 squared, which equals 5 times 3 squared, which equals 15 squared. But the point is, we need to recognize that this already is a perfect square, that 225 is 15 squared. So this equals the square root of 15 squared. And again, the square root of any value being squared equals that value. So this equals 15. And if we were looking at cube roots, we'd look for perfect cubes. If we were looking at fourth roots, we'd be looking at values that multiply by themselves 4 times are factors of what is under the radical. But with square roots, we're specifically looking at what perfect squares can we factor out under the radical.